Hello, welcome to my lab 4 on bar magnets. So the purpose of this lab was to measure the magnetic field impact of a bar magnet using our phone's magnetometer. We'd then use this to compare observed versus predicted values based on Biot-Savart's law. We do this both on-axis and off-axis for the magnetic field. And some previews of the results are that the n value was negative 3.3 and the magnetic dipole moment was 2.73. So here are the three fundamental principles we'll need for this lab. The first one relates a magnetic field at a point to a moving current, and then the second one is a more specific case of this for a magnetic dipole, which is the assumption we're making for the bar magnet. We also have this bar magnet formula, which will help us make a graph to get these values, but basically the magnitude of the magnetic field due to a bar magnet decays with distance. So the procedure we do first is to find the magnetometer on our phone. So as we did in lab, we use this tape to mark it off so that we can get this distance for our formula. So here's the data analysis I got for the on-axis values. As you can see in the left column is distance, right column is the magnetic field. Then you average these and we linearize this formula to get the n and ln of k values, which are important. Using these values, we can calculate the magnetic dipole moment, which was 2.73. We basically just use the values from this graph and plug it into the formula until we only have one unknown, and then we solve. So here we have the off-axis calculations, again very similar, and I just tabulated it in this sheet. So here our GlowScript computational model, we first have to initialize and then find arrows to represent the on-axis and off-axis magnetic fields. And then here also in the summary section, I showed where it shows a predicted, which was pretty similar to our actual results, but again, a little bit of variance. So what errors and assumptions did we make? Well, we assume the bar magnet acts as a dipole. The simplification helps a lot, but is probably not entirely true. We also assume that the magnetic field falls off as distance increases. This is a general truth about most forces, most of the four forces in the universe, so pretty good, but again, not exactly accurate. The things that could cause these errors would be that there's other magnetic fields in our room, there's currents moving as well as other magnets, so the superposition just compiles these and changes the data some. And then also we didn't exactly find the location of the magnetometer, nor would it be on the surface of the phone, but it's close enough. So what if we didn't orient with magnetic north? This would still yield the same process, but our results would be skewed just because this orientation helps us show the deviation just from the applied magnet. And then what if we connected two identical magnets? So if we took the bar magnets and they were the exact same and connected them, then the direction would stay the same, but the magnitude should increase by about twofold. So thank you for listening to this presentation. Hope you enjoyed your lab.